Today's stamp question is launching our new objective for this new section that you will be able to refresh and strengthen your prior knowledge of using function notation today to evaluate functions, tables, and graphs. So here we have a function. Is number one says find f of -2. Is that giving me a value for x or for y? For x. Very good. So remember, we read f of x. This does not mean f times x. F of x, where x is my input. So wherever I see x, what am I going to be plugging in? -2. So I've got -4 times -2 plus 20. Fantastic. Now let's just finish doing our algebra. What's -4 times -2? 8 plus 20? 28. Number 2 says find x given f of x equals -20. Go ahead and sit next to Lewis. Now, the question was asked, is this the same as number 1? Totally different. Can anybody tell me why this is totally different? It's good. So this means plug in for y and find x. Here, I knew x, right? I knew that x was -2. So, what's my setup going to look like? What's my equation going to look like? Great. Now what? Focus on this. I'm trying to get this by itself. Is there something on this side of the equation I could add or subtract? Corrections after. We have to be fair. It has to be right on your own for the stamp today. What's -20 minus 20? -40. Careful. Gotcha. -4x here. To finish this, what am I going to do to solve? This is what today is going to be all about, bringing back this knowledge. Can I have 2 volunteers to pass out today's notes? 1, 2. It's the stack on the podium. It has the picture of a shirt on the front. So while they pass out the notes for today, whoever got the stamp right on your own, go ahead and bring it up. Means you got 28. So the question was asked if you got 1 right. If you got 1 of the 2, we'll take that for today. Both right for tomorrow. That's fine. Same thing. The question was, is 10 equals x versus x equals 10? Is that the same thing? The answer is yes. So people who only got 1 right, make sure, especially if I'm putting a stamp on it, that you actually take a moment and correct what went wrong. That way this stamp, because right now the stamp means it's right. So for today, 1 right does count, but make sure you fix. Okay. Fantastic. Nice job. Last call for stamps. So tomorrow we're going to do another one, okay? And tomorrow is 1 right, okay? Or do you have to have both right tomorrow? Both. So we have something to shoot for. Good. Go ahead and start reading the notes. What's in the gray box is really kind of like a textbook insert, so to speak. So take a look. And now you'll see those giant capital refresher titles at the top. This is not new material. We're just bringing back knowledge from last year. Oh, credit card, the bank account question is due today, yes? Who's going to collect that for me? Somebody, go ahead, Ayana. You help me pass out. Let Ayana collect it. So, the extra credit also turn into Ayana if you did it. Thank you. Thank you. We just did our stamp question, and then the guys passed out the notes. They're on the podium. It's got a picture of a shirt on the front. So homework and extra credit to Ayana. Everyone else, we are reading today's notes. Where she is. Only the packet. That other one will be for later. Can you hand Samantha one of those? Or she'll get one. Nope. This. Okay, refresher. Function notation. Raise your hand now that we've started to talk about it. Raise your hand if you remember this from last year. Oh, everybody should have their hand up. I've got about 3/4 of you. If you're choosing not to vote, shame on you. Vote when I ask you to vote. Function notation is a way of representing functions algebraically. It makes it easier to recognize the independent variable, what you are plugging in, and the dependent variable, what is coming out. Like we just said, f of x is read f of x and indicates that x is my input, it's my IV. We can take an equation and write it two different ways using two different notations, and it doesn't change the meaning. And I put an example here for you side by side to show you that it's the exact same. So an example, Milan is starting his own clothing company. He tells a buyer that the cost of ordering shirts can be calculated using this model. Following what we've been doing, I'll stick that in a nice little box right there. There's my model, y equals 8x plus 15. Thank you. Where each shirt x, so x represents my shirts, costs $8 for a shirt, and a flat rate shipping cost of $15 is automatically applied. So check this out side by side. This is without function notation, and this is with function notation. Take a moment to look at each side by side. Yeah, so check this out. Lewis was commenting how here there's an x and here there's not. Here, we're saying y equals, we define our variables, f of x equals, define our variables. So pretty much up to here it's the same, right? But now let's look at when we do the math. Without function notation, I have to say something like let x equal 4. And then we do what we do, plug in 4. I get y equals 47. But if I asked you 6 months from now, how many shirts did they buy for $47? Would you be able to tell me? 6 months. I'll challenge you to that. Would you be able to tell me? I tell you the answer is $47. Would you remember how many shirts? No. Now let's go look over here. How would I read this out loud? F of 4. And this just stays. There's no math happening on this side. This is purely notation. Eyes on the screen? Eyes on the screen? So it's going to say f of 4 every time. F of 4, and so on. So here's my answer. We get the same answer. We get 47 both times, yes? But 6 months from now, I ask you how many shirts did you buy? What can you tell me? 4. F of 4. So it's a notation that keeps track of what you plugged in. Let me say that again. It's a notation that keeps track of what you plug in. That's it. Don't overthink it. So, with our warm-up in mind, our stamp question, please go ahead and use the equation f of x equals 8x plus 15 to evaluate for each. And then also, what does it mean as it applies to the real-world scenario? F of 9 is first. Go for it. Using this model. It's like, so the question is, what do you do when you get to C and D? Great question. That's like number 2 from the stamp question, where I'm given the output. Hmm? Pause once you have A and B done. Pause once you have A and B done. Do we get the same answers for A and B? Are we done answering A and B? No. What did it say in the directions? So what does this actually mean in this real world scenario? Use your teacher voice. You're right, but nobody can hear you. Go for it. Very good. 9 shirts. Cost $87. $87. How does that make sense? So somebody just commented correctly that 0 shirts costs 15. How does that make sense? That's what they cost. No, it says 0 shirts cost $15. What's that? What is that called? A flat rate or a flat fee? So before, as soon as you go to buy something, right away, what's a cost? Unless it's free. What do you have to pay for? Shipping. So that really represents the flat rate charge for shipping. Now, instead of knowing how many shirts I'm buying, what do I know? $15 is the shipping. So remember how we define the variables up here. My inputs represents number of shirts, yes? So this was I buy 9 shirts. How much? I don't buy any shirts. I already have to pay that much. If I know my output values, what do I know? How is Y defined? What's the definition of Y? It's not a trick question. What's Y represent? Cost of the order. So now you're saying in C, how much money do you have to spend? Can you find out how many shirts you can buy? Go for it. How many shirts? Let me know when you have an answer. Nice job. So that's my math answer. But what's my real world answer? Yep, very good. So you can afford to buy 20 shirts. Some version of that. There's many ways to write that sentence, but you can afford to buy 20 shirts if you have that much money. D is asking if you have how much money? How much do you have to spend in question D? Yeah, so instead of having $175, now let's say I only have $151 to spend. Let's see how many shirts you can buy. I hear one vote for 17. Let's see if you all agree with that. Everybody's getting 17? So let me just catch up with the notes. What's 151 minus 15? And then I divide by 8, both sides. Very good. Good job. And then however you choose to write your sentence, if it says write a sentence, we have to write a sentence. So here's a little bit different way of writing it. It means the same thing. You can buy 17 shirts with $151. Or if you have $151, you can buy 17 shirts. Nice job. So this is working with functions. See how the title of this is functions as equations? What are we going to look at next? Turn the page. What does it say? What's the title? Functions as tables. So we looked at equations. Now we're going to go through tables. Go ahead and read the scenario. It's brief at the top. The function h of a represents the average height of boys that are a years old. So what are my two variables? Good. So let's define those. A and h of a. What's a? Oh, careful. Number of years old or age, however you want to write that. And then what is h of a? Average height measured in, does it say feet? Read carefully. Inches. Okay. Now, use the table to evaluate the function at each value. Explain what each means in terms of the scenario. What's great about tables? No math to do, really. Because check this out. In question A, do I have an input or an output? Input. What's my input? 7. So I want to know when a boy is 7 years old. So what am I going to do on this table? So at 7 years old, 7 years old, 49 inches tall. If you don't want to write out a full sentence, I'll even take that. Just tell me that you know what these numbers mean. B is kind of interesting. What is B asking? So this needs a little bit of math. How many years old is this? What does this mean? Year and a half? But I need month. I don't have a 1.5. So where am I in the months for this? 18. Halfway between 12 and then this would be my 24, right? 24 months? 18 months. Yes. So at 18 months, what's the height? 18 months? 34. Get what? Which part? The 1.5 part? A year? So let's break it down that way. That's a great idea. How many months in a year? 12. How many months in half of a year? 6. 12 plus 6? 18 months. I didn't say so. That was for part A. 7 was part of part A. We're on B. Okay. So this means 1.5 years old. How tall? Fantastic. How about, can you do C and D on your own? Alright, go for it. And then we'll compare. we're given inputs. These are values for x. This is a value for x. In my table, my x values are here on the left. So this is asking, when the boy is 11 years old, what's his height? So I say, okay, here's his age, 11 years old, what's his height? So for this table to exist, somebody has already done all the math. They've plugged in all of these values and gotten all of these numbers. We are just analyzing the table. Do we match in our answers for C and D? Good. Now what's different about number 3? I'm given the heights. What do I not know? The age. So let's do we'll do the same thing. We'll do A and B together, and then you do C and D. So, David, check it out. Now I know my heights. I know something about the height, but I don't know the age. So this says the boy is how tall? 61 inches. So I go 61. If the boy is 61 inches, how old is he? So I write A equals 13 as my math answer, but that means 61 inches tall means he's 13 years old. So now we're going the other way. We're starting with the height and finding their age. Need me to do one more, or can you do these 3? Go for it. Make sure we have the real world meaning, not just the numbers. No. Yeah, this last one's a little interesting. Yeah, well, not exactly, because I was thinking the same thing. But halfway between 44 and 47 is more like 45.5. No, the 5 is right to start. More like 5.4, but who says you're 5.4 years old or 5.3? So how about we just say approximately? Like, do you remember how to do that little wavy equal sign? Approximately 5.5. So 45 inches tall, approximately 5.5 years old. Okay, we have conquered tables. What's next? Graphs. Love graphs. Do you love graphs? I love graphs. Functions as graphs. The function d of t represents Gulliver's distance from home after t hours. So I was given some variables. What does d of t represent? Distance. And t? Hours. I want it to be second nature for us to be defining variables all the time. So t equals t is hours, d of t, my output, distance. How is distance being measured? How do you know that? Fantastic. He said because it's on the y-axis. So when I have a graph, what's very nice is almost always if a graph is provided, let's say I missed it from the reading information, here's x, Here's y. I look at the labels. Here's my hours. Here's my miles. How nice is that? So let's look at our first set of questions. It says, use the graph to evaluate the function at each value. Explain what each means in terms of the real-world scenario. So, in 4a, am I being given an input or an output? Is this giving me an input or an output? Input. Very good. So where are my inputs located? X-axis or Y-axis? So where am I going to go on my X-axis? I go to 2, and now what am I going to look for? So like if you have a pencil, you can like lightly do this. Nothing dark because it doesn't really exist. It's like a mental line. Where is that? But what does it mean? What does this mean? It's right. You're right. But what does it mean? What do you know first? What did you know? So in 2 hours, went 4 miles. Yes. But is this really even a sentence? No. So if you don't want to, I like full sentences, but I realize not everyone does. This is a happy medium. In 2 hours, went 4 miles. Can you do B and C and D? Where? Go for it, and we'll compare answers. .9 is going to, what happened when, we'll talk about this, but see how this is flat? What was he doing? He stopped. So how much of a break did he take in his ride? An hour break. He chilled somewhere for an hour. So at 2.9 hours, he still was in the same place. Yep. You could say in or at, however you want to say it, at 2.9 hours. Let's see. D of 10. So we've been saying went 4 miles, but the distance was distance from where? Distance from home. So really, this is like went 4 miles away from home. 11 miles away from home. So that's where we have to really make sure we check what are we talking about. Still 4 miles, right? And then here, D of 10 equals, what did it equal? But what does that represent as a distance? 0. So after 10 hours, he's back home. Language. Okay, but now in question 5, what do you know? You know the opposite. It says calculate the value of t that makes each of these true. Explain what it means. So is this an input or an output? Output. Where are your outputs located? On the y-axis. So now I know his distance from home. I don't know at what times. Now before we start answering these questions, I want you to really look at this graph and understand what it means. This is he's traveling towards home or away from home? Away. He stops, and then what is he starting to do? Going back home. So when you travel and you come back, think about that. You're going to pass the same distance twice. So for 2, what does this 2 mean? Like this 2 is connected to over here. 2 miles from home. So at 1 hour, and again at what time? 9? 9.5. So t equals 2 and t equals 9.5. There's 2 answers. You don't. He's asking, can we say 9:30 as a time? We don't know what time he started his ride. Right? If I knew that this was 12, take a look. If my 0 hour was defined as 12 noon, you would be right. That would be 9:30. That's a great question. But right now we're just talking number of hours. So 2 miles away from home after how many hours? Hold on, let's finish this. After 2 hours and 9.5 hours. Where? 2 miles away from home after 2 hours and 9 hours. Did I write something wrong? 2 miles? No, 1. Ooh, yes, thank you. I wrote an extra 2. This is 1. Good catch. 1 hour. I got too happy right there. Get it? Too happy? Okay, never mind. I'll keep that joke to myself. 1 hour and 9.5 hours. Great. Fantastic. What are my answers for B? What times? 4, 8.5. Go for it. Finish. In this case, yes. So what are my 2 times for 5 miles away? How many hours? 5 and I don't really have space because of the marker to continue these sentences, but can you? Yes. Yes, you can. What are my times, how many hours for 4 miles away? This is interesting, because I have to account. How am I going to account for this break? Excuse me, Shamar. Please stop talking. Between hours 2 and 3, can we do like that, bringing back our domain knowledge? Woo, interval notation. Because otherwise, there's 2 hours and 1 minute. There's 2 hours and 5 minutes and 27 seconds. So that is how we can indicate this entire piece of time. Yes, David? Yes. I'm given the distance. I'm finding the time. We're saying when y is 4. When y is 4, what's x? I know this. I don't know at what time. No, I look at my graph. So at 4, it's right here. And then again, on the way home, at what time? Is that 10's over here? What's back here? This is 8, this is 9. So that's like 8 point what? What do you want to call that? Ashley, go ahead and work sitting up. 8.8 hours. So the way that you would describe that in words is between hours 2 and 3. and then at hour 8.8. Let's take a look. So here's 0, right? The question is 0. I've got 1 point, and then again right here. So what's my answer for that? What he said was perfect. Did you hear what he said? Anybody hear what Davion said? What did he say? You. So the 0 hour, you start at home, hour 0, and then when you return home, I keep writing the same thing. You start at home, hour 0. After how many hours? And if you're home, this is kind of a trick, not a trick question, but it sounds funny. If you're home, how many miles are you away from home? 0. Very good. So we have now covered how to use function or tables in what 3 ways? What was the first one? Equations, then tables, then graphs. So we're now ready to practice. Can I have 2 volunteers to pass out tonight's homework? Faith hasn't helped me out yet. Who else hasn't helped me out yet today? Go ahead. Grab the stack. It's on the right. And we're going to start the homework right away. Use your notes from today. We have some time. Let's get started on tonight's homework. Nice job today.